Okay, so we will give some update on Qubes Air. That is finally something is happening in this area. So what is it? It's the idea that we posted some high-level design 6 years ago. I will show some motivation. What is it? And show some of the design of some of the parts that we are working on now, and what we are leaving out for later. So why? What is it? Basically, the current Qubes OS version is a system you put on one computer, and you have several virtual machines that you can manage. Currently, we support only Zen as a hypervisor. There were some community attempts on supporting KVM. I think they're quite advanced from what I remember, but still, this is a single system with virtual machines. So the idea is to extend this for multiple physical systems. So we have a lot of nice integrations that you can, for example, copy files between VMs, or keep your keys, SSH keys, GPG keys, FIDO keys in some other place, and then use them in different VMs. So maybe we could extend this idea of running different VMs on different Qubes in different places beyond a single system. So we can, for example, have a separate system which we consider much more trusted, and use it for storing keys, and don't worry that some speculative execution CPU bug will be used to steal our keys from the system. We are, I don't know, random executables downloaded from the internet. Yeah. So, or maybe just have some optimization, like you have some light and convenient laptop, but it's not very powerful. But also you have some big workstation with a lot of memory, a lot of storage, and you can use it for some data storage, data processing, but still use those capabilities on your convenient machine, convenient laptop. There are many use cases like this, and if we extend this idea a bit more, then this other system may not even be a Qubes OS system. We can extend it to also connect to other systems, like treat a Raspberry Pi as a single cube and connect it to it, or maybe connect to some cloud instance also as a cube. And we have QRexec policy that can control what those entities can do. So maybe you can, I don't know, upload your photos to some, I don't know, some cloud service, but keep your emails locally, for example. There are many options. And this is actually something that some subset of that very small part was actually implemented in the past. There was a project that used USB armory for split GPG. So there was a QRexec tunneling to USB armory, which is a small computer with Linux connected basically on a USB stick with ARM CPU, and there was in that version it provides the emulated network interface on the Linux the USB armory side, and there was a tunneling of QRexec connection from some VM according to the policy to sys-USB that connected over this emulated network to USB armory and then performed the signing operation on the USB armory. So yeah, some proof of concept like this existed. The project was a proof of concept lab showing capabilities of the USB armory device. Yeah, but it was very nice, and it showed that this capability is something that people find useful. So what we decided to build now is focus on QRexec connection alone for now. So we have different systems. It can be two Qubes OS systems or Qubes OS and some ordinary Linux. We will focus on two Qubes OS systems for now. And we add enough support to make QRexec calls from a cube on one system to a cube to another system, and that's all for the base support. Maybe we will see. We will manage to add enough capabilities to also start disposable cubes on the other systems. This would be very useful, but it's more complicated than we currently plan. What is out of scope in this version? We are not doing any GUI support for now. So if it's only for some QRexec services that are just passing data back and forth, so you cannot. Well, you can start the graphical application on the other system, but its interface will be on this other system, not on your. It won't be like forwarded back to your system. And there is in this first version, all the provisioning is just registering individual cubes from one system to the other, and it needs to be done on both sides. We will try to provide some scripting for that, to do that like semi-automatically, but it still focuses on individual VMs on both systems, not like automatically synchronize all the state of the one Qubes machine to the other and stuff like that. This maybe will come later, but not in this iteration. Okay. So the current idea is to introduce new cube type, and I think Frederick can show.
Yeah, sure. So yes, following what Marek said, we are going to introduce new objects, and notably what we call the remote VM. So it will be simply a remote cube. If some of you already look at the base code of Qubes, inside the Python code, there is some class that defines the Qubes VM, this template VM, anything like that. So what we will call here a local cube is formally what is called a Qubes VM inside the code. So we need first, before going into this subject, to slightly adapt some piece of the current code of Qubes, and so we will try to stick to some terms that say that when we speak of a remote cube, it will be something, of course, elsewhere from your station, that your local cubes, and what we call local cube will be the standard cubes that you have already. So a remote cube will be some general term to say that we are going to make some RPC requests to some entity. So as Marek said, it could be some Qubes OS instance already, so it will be some other cubes on another machine, but it could be also some Raspberry Pi, KVM VM, and so on. And so basically, for example, we might implement some disposable VMs creation on a remote system. So if you think of the new builder, we use a lot of disposable VM to build stuff. And so that will be some very nice case of using some machines to have some intensive builds from your local Qubes OS. So, assuming that you have a remote cube somewhere, we need to make some communication between your local Qubes OS and your remote Qubes OS, and then we will need to introduce another type of cube. So we had some kind of discussion with the community to say how we will call that, because the first idea was to say that we will need some proxy, but in Qubes OS there is already some proxy cubes that exist. So we converge to say that we will need some relay cube, so they will act as a proxy, in fact. So you will have two relay, one on your local machine and one on your remote machine, and this is this new type of cube that will forward the request that you will do on your local Qubes OS to your remote Qubes OS. They will go through these relays. We will show you some example. So. Yes, we just listed two types of RPC requests. For example, when we did the proof of concept with Simon 2 years ago, we implicitly defined two relay and two cubes, and we use SSH to say, okay, I want to make some QExec call. I will just use SSH to finally call the QExec on the remote host to make the call. So we will show you some example, I think, on the next picture. No.
Yeah, you have the graph on the next one.
Okay.
And then description here. You can switch back and forth.
Okay, I will switch on the description, yeah. So the idea is to make some communication between your local Qubes OS and your remote Qubes OS. So assuming that you have a local cube on your local Qubes OS, I will precisely insist on the terms just for you to see exactly about what we. Well, yeah. Oh, it works. So you have local cube. So it's normal. For example, your personal cube on your local Qubes OS machine. So imagine it's a laptop. You have also some cube on it, which is a local relay. And assuming you have another Qubes OS somewhere else, for example at home or somewhere, so it's called a remote Qubes OS. On it, you have a remote relay and a remote cube, so your destination cube on which you want to perform an action. So making a QExec call from local cube to remote cube, it will be a matter of several steps. I hope you can see the text on it. Is it fine? Okay. So first of all, you imagine you want to copy, so you will call the QVM copy RPC as if you will do as usual. You will be prompted to say, okay, what is my destination cube as usual? You will have in the list simply remote cube. Really as if you will do it as usual. So you will have some RPC process to check, are you authorized or not. So typically, have you accept or not the RPC, and then it's there where we need to now introduce more steps in the processing to simply transform the current QExec request into another request, if I can say so, using what I called before the transport RPC. So basically, when you QExec something, we will wrap into SSH, for example, that we will need to QExec call the final destination with some arguments and some service that we requested from the original cube to make it work. So we do the wrapping of the QExec call. We do the execution. So basically, for example, SSH, the destination execute QExec on this cube, and then the local the remote Qubes OS instance receive from the local relay. So it's a remote relay that will initiate finally the QExec call to say I want to execute the copy of the given file to the destination cube, which is remote cube, and then the remote Qubes OS check that you are allowed to QR exec from remote relay to remote cube, and then if you have the right to do so, you simply going back to the original cube. So through first the QR exec protocol, then the transport RPC method, so SSH network, the network stack, and then QR exec stack, and you follow back to the original initiator. So the steps are basically this one. So the one I tried to explain. I hope it was clear. So this one, and so when we spoke about to have possibly just only physical machine or even VM that are not from Qubes, in that case we need to specialize a bit. So relay VM is at first a remote VM, so the more general remote class is a remote VM, then on which you can specialize this remote VM to be a relay VM. But in the case of, for example, just one non-Qubes machine, we won't define remote cube. If I take my previous example, there is no remote cube on a Raspberry Pi, for example. So, in fact, the Raspberry Pi will directly be the remote relay itself. Speaking of network connection, you will reach the Raspberry Pi, and in fact, you will reach the remote, what is called here a remote relay. I think we have some
there's a
diagram. Yeah. So it's simplified to that in fact for a physical machine or a standard VM and so on which you can reach it by using network. In that case, the relay and the remote Qubes OS host, of course, and the cube is itself the same entity registered in the local Qubes OS. So steps.
Steps?
No.
Then the next one?
No, this one, sorry. Oops.
Yeah,
Okay.
so that's.
So, as you can see, there will be a lot of issues to manage such thing, because here you need to. There is some issue with trust, notably when one imagine your remote Qubes receive some request from a relay VM. So in that case, it's the remote relay that say, "Hey, please execute some RPC from somewhere else, another Qubes." So for example, if you chain several relays, so imagine if you think about SSH jump host, you will just jump over several hosts, and the remote Qubes OS knows that you will allow some requests from this particular relay, which is called a remote relay. Anything that comes through the local cube. So what we are facing right now is that we will say on, for example, on the remote cubes, that you will accept requests that come from this particular remote relay, but we have some issue to say we are really sure that the original VM, so the local cube that initiates the communication, is really that the one you want to be sure. So that's why we might in the future implement some end-to-end verification. For example, sharing some secret between your local cube and the remote cube to be sure that in the process in between there is nothing that could change the content or anything else.
Yeah, and this is also the a potential for some more use for anti-wheel mate to have some kind of remote assistation. If you are connecting to real Qubes OS, that is still unchanged since the last time. But yeah, that's way in the future.
Yes, but basically, we also made several. Precision, I mean, the particular case of using dedicated resource and so on is also nice. But if we take also the example of having your keys somewhere, it's easier to travel and say, okay, I'm potentially able to even and Lux, or even you know, if I follow the presentation of this morning, you can have some relay VM which will be properly encrypted and so on, and so you can also use your keys which are somewhere else, safe, in a safe place, and even if someone is pushing you to unlock your computer and so on, you can somehow prevent him to use your key, as if you would use speed GPG even locally, but at least your keys are safe in a safe place. So it's also a good case.
Yeah, and I have a few more words to say about provisioning this thing. So you've seen on the diagram there are a lot of moving parts, and there are a lot of this relay VMs, remote VMs, local VMs, etc. And to make a single connection, we need several objects to be configured. So manually, it would be a lot of manual work. We will do that during development, but that's not the nice way for the user to do. So we plan to have some provisioning tool which you will tell, okay, I want to connect this local VM with this remote VM on this host using SSH transport, and it will generate all the configuration, SSH keys, etc., and give you a package you can automatically transfer to the other host, and some random idea for the how to do that in a trustworthy way is to use something like magic wormhole, where you have you can transfer data over the network in an encrypted and authenticated way. So you have one host where you run this tool, it prepares all the configuration, and you on the other host you run the tool to apply this configuration. You type the code words. It's like 3 or 4 words you need to type, and it downloads the file. It's verified. It's if it matches, and then it will apply the configuration, and you have the connection established. We will, at some point, we will likely improve this to make it a bit more automatic, but this authentication step needs to happen at some point. So that's the idea from the user perspective. Make the connection one, okay, type this 4 words on the other host, so you go to the other host, type those 4 words to confirm, and if they match, then connection is established. We'll see how it goes in practice. This is this design exists only on this slide for now, so we'll see. And from the management, after you make the connection, there will be not much for now. So there is the remote cube type will have very limited set of the metadata. It will have name and what relay should be used to communicate with that, and that's probably all. Maybe a color.
Yes,
maybe, but there won't be any information about its state, whether it's running or not, is it network connected or not, what template it uses, nothing like this. All the actual configuration of the cube still stays locally. We will try to add enough API to enable starting disposable cubes on the other host, because we find this as very useful use case, but full remote management is not part of this design, at least not yet. We will see. Yeah, and the reason for having this API this limited is to not require to have Qubes OS on the other side. We want this to be compatible also with like Raspberry Pi or some cloud VM or something, or even start a disposable VM, which is actually some spot instance or Amazon or whatever else. So we want to keep the API very limited to be able to add integration with many different types and other APIs. If we require everything to support this 40 properties, then it would be much harder to make it compatible with different things.
Yes.
Yeah, and
I can also just make something is that yes, even locally, if you define some management VM, it does a lot of QRexec, calls to retrieve property and so on. And so if we go to the way of saying, okay, my remote relay has also a lot of management permission on the remote cubes, we will have some challenge to say maybe we can manage better with the Qube manager itself locally, the remote cubes on the remote Qubes OS. And this is why we will need probably some very nice design and user experience from our dear Marta there.
she's hiding.
So yes, we will face some challenge with network and so on. So yes, there is also, this is why I said earlier that we have already several parts inside the Qubes code to adapt and to prepare to be sure that we will probably face these problems correctly. Yeah.
Hi. When you say about end-to-end verification, does the remote cube can assert the local cube is the same, or is like on the proxy level, just the relays can communicate and the relay could lie?
Yeah, so the initial idea is to leave this trust to at the relay level. So if you have several remote cubes, we will verify if cube 1 is communicating using correct relay. So if relay B says, hey, VM1 is trying to communicate, but VM1 is supposed to use relay A and not relay B, it will get rejected. But the identity of the remote VM behind the relay is not not part of the initial design. It could lie. It's if you have 5 different VMs behind a single relay, that single relay can lie which of those 5 VMs it is. If in this design at this level, if you care very much about this identity, use one relay per one VM. It's less efficient, but more you will have this property. We can extend it in the future, we will see, but the initial part will not have this part.
Okay, and will it require a change in the QRexec policy?
So our current plan is to not require changes. We will see. That's the idea why we register those remote VMs objects, so you can specify them as the at the policy level, similar to local VMs. Maybe we will add some special tags to say they are from remote, or maybe something like that. But we try to keep it compatible with the current QRexec.
But basically, for now, the only change that we need for now it's just adding it's just exposing the source. We don't expose the source inside the QRexec message. So now we add explicitly the source, but somehow it needs to be trusted.
Yeah, so there will be a change inside QRexec implementation and the QRexec protocol, but not the policy format. That's the current plan. We'll see.
Okay, thank you very much.
Thanks so much. That's extremely exciting. I'm wondering if you can speak a little bit more to the changes inside the QRexec protocol that you're describing. Specifically, do you have design thinking now around what format data will be passed by RPC between the remote and the local domains? And have you thought about, do you have design thinking on that we can learn along with?
We have some design draft there. It will change probably, but for the like on the QRexec level between the relay and the DOM0, we need, like Frederick said, one extra information what remote VM behind that relay was sending that message. So that's currently the only change in the protocol itself. The other thing is this transport protocol, which we probably will pass all the data as inside the SSH for the SSH transport, as SSH as the standard input and output, and pass the argument on the command line on the SSH call. That's the current idea. Whether it will work efficiently, we will see.
If I can ask a follow-up question. So this is relevant not just for the idea of like the remote to local connection, but also in terms of thinking about how are we going to process data between VMs on the same machine. Sometimes we've run into questions about can we pack enough data into an RPC call, or is there a need for like a more rich format that can pass more information back and forth? And so I'm wondering if that fits into this design as well.
Yeah, we know this complaint. So yeah, this is something we don't touch in this design really, because the QRexec remains as a like data pipe between start and end. There is no forced any protocol. One thing that we did extend it in 4.2, the argument to a QRexec call can be way longer now. Yeah. It's 60 something kilobytes. So you can pack a lot of data in the argument itself, but you have some limited character set to encode.
Yeah. Super exciting. Thanks so much.
For the record, we faced this problem using Windows build executor.
Yeah,
command line was too big.
Yeah, thank you really much also, and also really exciting. And so the first question is kind of what's kind of the timeline here? Yeah, that's basically the first question. Okay. When this, what you just showed?
The current plan is to have the base version, base scope I showed in the one of the initial slide, included in 4.3. So that's
clever way to not answer the question.
I know I didn't set any time about that, but
well, you threatened with feature freeze at the end of this year for 4.3, so
that's not public information. Yeah. Yeah, so that's the current plan. As usual, we'll see. Historically, we try to release Qubes version every 2 years, so you have some idea.
So we don't have to wait 6 more years.
Hopefully not.
Nice. Good to hear an update on Qubes Air after quite a while. So if basically like remote VM is derived from Qubes VM, what does this mean regarding the concepts of app VMs, disposables, templates? Will there also be remote disposable?
The current plan is no. That will be hidden. So you can have a remote VM that is a template or is app VM or something. We don't transfer this information. The remote VM is a single type which encodes some remote entity. Okay. That's the current plan. Maybe we'll extend it at some point, but we want to keep it simple, to be flexible, because the other end may not be even a Qubes system. Right? It can be a Raspberry Pi with a single Linux system there. So yeah, that's the current idea. We'll see.
Makes sense. And then I also wanted to ask, so I didn't fully get the diagram. I don't remember if there is like a remote policy thing. Okay, yes. So the policy is decided by the remote system and not by the host.
Both, actually.
Okay, yeah. You need to consent to sending something to the other one, and then on the other one, like for example, if we have like split GPG, the other one is the one who decides if it allows this policy
Yes,
from this remote.
exactly. Both sides need to agree.
Okay.
This is extension of the initial design where there was some primary instance. I should probably avoid using word master, but the primary instance and other instances are some clones. Here we have. We don't have like it's on the same level. No of those local or remote DOM0 is have more privileges of another. It's symmetrical here.
Okay, sounds good.
So basically,
You can have more of them. You can have cloud of cube systems.
Exactly.
So, yeah.
Yeah.
Basically-
Some mesh network,
And in this consideration, because the problem seems quite similar, maybe there is also some space for solving the problem of remote of policies for admin VMs, of like where that should be decided and how that can be decided. Because it doesn't have to be solved with this. I just think that it's a related problem.
There is one related, well, not directly related to this, but somebody come with idea of having multiple tags in a single policy rule. So that's helpful a bit. I have some more ideas, but they are not designed enough to even put on any slides. So.
Okay, sounds good. Thanks.
Yeah, you mentioned this problem of proxy. Is it am I talking to real one or proxy one? So it seems that you're facing the root of trust for identity problem. Yeah.
Yeah.
So, and your solution right now is pairing based on something that on both sides is known. Yeah.
Yes.
So, but first of all, like a root of trust for identity, like this solution is very well discussed in Calyptra. And all this TPM DICE related things, and you mentioned anti-evil mail, so maybe this is the answer will be related. Does it make sense to go into direction of realizing what's the state of the platform, and if the state does not reflect the real identity of the platform we're talking with? That's one question. And second question about this pairing. This is sounds very weird because how I would know at the point of establishing connection, these images or these words, whatever, will be on both sides. I don't know. I'm in other country. I want to connect, and how I will realize at this point? I cannot realize at this point.
That pairing actually is very similar to verifying signal fingerprint or any other fingerprint. You need some other channel to transfer these code words to the other side. If it's your friend computer, you simply can call him and
ask. Okay.
Type those 4 words if you trust me or something.
Yeah.
But to answer your first question, right now we established this trust on this initial setup based on magic wormhole or something similar, and then both sides have some secrets. In case of SSH, it's host key and the user key, so there is mutual authentication here, but at some point we may also extend it with some remote attestation based on DRTM, so we can also verify if the remote site is still the same, if not somebody replaced the hypervisor or something. But for that to be meaningful at all, we need some version with locked down DOM0, because it doesn't say anything about the state, what QRexec will do if you verify just the hypervisor, because DOM0 can do anything. So for that to be meaningful, we need a bit more locked down DOM0, which may or may not come in the future in some of the version of configuration. We'll see.
But about the release schedule roadmap, is there for R4.3, is there even a milestone on GitHub or something which gathers all this, so you can see?
There used to be. I'm not sure if GitHub did something funny to the GitHub project.
But maybe other way. How are you tracking that? It's in your head or somewhere?
No,
else?
there is some issue.
It's in your head.
Yeah,
that's bad.
There is physical representation.
There is very small buzz factor here.
Yes, there is physical representation. I have stickers Yeah, but I will put that on GitHub.
Okay.
Yeah. But yeah, but you can track the work done on this particular issue. This one. Yeah.
Hey, super interested in how all the authentication is going to work out on sort of setup and on these individual calls. I was reminded of the idea from earlier of UUID identities. Seems will be more useful when when you're on another machine, and I wonder if you can tie that to something like a public key for the sender that signs it. I don't know. What was more of a question was what additional challenges do you think you'll get sending RPC over a network now, so that classic problems of your transmission is lost or delayed? Does the current protocol has some timeouts and things, I assume, already to accommodate for some of that?
Yes, so the current, this will require some more work because the current protocol have some timeouts on the connection setup. So if the connection, the other connection, you cannot reach the other host, it will, I think there is 1 minute timeout, half minute, something like that. So this part is there, but if your connection dies past the, in the middle,
That will fail.
no, it will wait forever, basically. So yeah, this will need some improvement. So that's basically up to this transport service. SSH will time out eventually.
Sure.
If we use, I don't know, TCP over WireGuard, this will also time out eventually if it doesn't work. So it's up to the transport service. But yes, those timeouts may be long and may be inconvenient. So we'll see how it works in practice.
Yeah, fun problems.
Yes.
So you mean we will have some transport that will manage retry?
We'll see. It's not, there are problems there, but we'll see.
Yeah, I wonder if those are questions from Demi about could CAP and Proto RPC be used? I guess, is it related to that? Is it sounds like related?
Current ideas are about using existing, for example, SSH transport and not encoding extra data. We have that protocol, QRexec protocol already. We don't need anything new there. We specifically make it that the transport services, we can use different transport services for different relays, different remote cubes. So yeah, if somebody wants to write something new,
yeah, contribution welcome.
Yeah, we have specifically, we are not hard coding. It must be SSH or something. It's flexible that you can choose different options. You can use, I don't know,
Android
notes or
attestation,
something.
like Demi suggests also Android attestation.
Yeah, if you connect to something, maybe. So there are some ideas. We'd like to keep the initial plan, initial design simple and flexible enough that we can actually deliver something in time, and also we can also extend it for some other use cases later. Okay, so I guess.